Hi, so for my Internet of Things laboratory subject, this is experiment 4. It is entitled Explore the Smart Home. So to start the experiment, let's download a BKA file. So I already downloaded mine and opened it in Cisco Packet Tracer version 7.2.1. So it is important that you use that version and not the new version because these equipments or the um, devices here will not work if you use the newer version. So to start the experiment, um, the objectives of this experiment is to explore the smart home and to analyze the usage of fog computing in the smart home. Background or scenario: in this activity, you will explore the smart home example. Depending on the application, some data is best processed close to the source. The smart home example takes advantage of fog computing to monitor and act upon the levels of smoke detected in the home. So part 1, explore the smart home. Understanding the devices that comprise the smart home. Commonly, ISPs deliver data and video over a single coaxial cable. Starting from the attic, here, the coaxial splitter is used to separate the video signal from the data signal. So this is the coaxial splitter. So as you can see, just as what was stated, it is used to separate the video signal from the data signal. So two coaxial cables leave the coaxial splitter in the topology shown. Which devices does the coaxial cable connect to? So as you can observe, here's the attic and this is the coaxial cable, and the devices that the coaxial cable connect to are the cable modem and the TV. So the cable modem is the interface between the ISP's network and the home network. To which devices does the cable modem connect to? So as you can observe, the cable modem is connected to the home gateway. The home gateway acts as a concentrator and router to all internet home devices. It also provides web-based interface that allows users to monitor and control various smart home devices. Notice that the home devices can connect the home gateway through either a wireless and/or wired connection. Note, Packet Tracer uses dashed beams to represent wireless connections, but it can make hard to read when too many devices are present. To turn it on, go to Options, Preferences, Hide tab, uncheck hide wireless or cellular connection. So let's do that. Let's go to Options, Preferences, Hide tab, and let's uncheck this. Now we can see all the devices connected to the home gateway. So we need to list all home devices connected to the home gateway. So as you can see here, smart window, smart lamp, the smartphone is connected. Also tablet, smart fan, smoke detector, smart alarm, what else? The smart water meter, smart sprinkler, the temperature meter, the not the smoke sensor, smart coffee maker, and smart door, also the garage door there. So we're done in exploring the smart homes. Now let's go to step 2, interacting with the smart home. The devices in the smart home can be monitored and controlled remotely through any computer in the home. Because all smart devices connect to the home gateway, which hosts a web-based interface, tablets, smartphones, laptops, or desktops computers can be used to interact with the smart devices. So let's do that. We need to click on the tablet. So click on tablet in the master's bedroom. And click on desktop, web browser, and type this IP. Let's just copy it and paste it. And username, admin, and admin password. So what is displayed? So as we can see here, it displayed all the home devices connected to the home gateway. So the smart detector, smart lamp, also the list that was said here earlier. So let's next, the smart door is currently unlocked, represented by a green light on its doorknob. So let's check. There's the green light. So it's unlocked. So it says here that we can remotely unlock the or lock the door. So click the smart door in the browser and expand the option. So as you can see here, it's open. So we need to do is click on lock, and question was the door locked? How do you know? So here we can observe the smart doors knob is now color red instead of color green. So now we can say that it is locked. So click on lock to unlock the door. So there, it's unlocked again. Next, click the smoke detector in the browser. Smoke detector. To expand the section, what is the smoke level reading provided by the smoke detector? It says here that level is 0. Can the smoke detector be controlled? No, the smoke detector cannot be controlled. Smart devices can also be controlled directly, representing physical interaction. Within the logical work area of Packet Tracer, hold down the Alt key and click the smart coffee maker to turn it on or off. So let's try that. I'm pressing on Alt now, and let's press on the coffee maker. As we can observe, the coffee maker's LED indicator turns red, and when I click it again, it turns off. There. Part 2, fog computing in the smart home. The MCU added to the smart home is used to monitor the smoke levels, read by the smoke sensor, and decide if the house should be ventilated. If the carbon monoxide levels raises above 10.3 units, the MCU is programmed to automatically open the window, front door, garage door, and start the fan in high speed. This action is only reverted, close doors and windows, and stop the fan when the carbon monoxide levels drop down below 1 unit. So step 1, run the classic car. The owner keeps a classic car in the garage and needs to be run occasionally. The classic car generates carbon monoxide, which raises the levels within the premises. So step 1, we need to click on the tablet and located on the master bedroom. So it's here. And now we need to navigate to desktop. We are now on desktop, and in the web browser, let's type again the same IP address that we used earlier, and admin is still for the username and the password. And now we click on the smoke detector rather, and leave this window so we can observe what the monitor will read if we says here, start the car engine by holding Alt key and clicking the classic car. So let's do that. First, let me just there, and so we're going to observe this level. I'm clicking on Alt key now. There, as you can observe, there's an animation for the carbon monoxide. So as you can see and observe, the level of the carbon monoxide increases when I turned on the classic car. There. Next question. What happens to the air inside the house after the MCU opens the doors and windows and start the fan? As we can observe, it opened, the smart window opened, the smart door opened, and what else? The fan is now at high setting. There. While still monitoring the level, stop the classic car's engine by holding the Alt key and clicking the classic car. What happens to air quality inside the house after the engine has stopped? So we need to open the tablet again for that. So this is the level. Let's turn off the car. And as we can observe, the level of the air is now 0 inside the house. What happens to the doors, window, and fan? Now, we can observe that since the level is now 0 or the air is fine inside, the smart door, the smart window, the smart door, and the fan turned off. Turned off and closed. There. So I guess we're done. For the part 3 reflection, this example shows the decision between cloud and fog processing depends on the application. In the smart home example, fog computing was the best option. In the smart home example, the data gathered by the smoke sensors were processed and used to make decisions regarding the house air quality. In this scenario, there was no need to send out sensor data to the cloud for processing. Cloud processing would slow down the response time, potentially putting lives in danger. Another possible problem relates to the internet link. If the connection to the internet was lost, the entire system would fail, putting lives at risk. So there.